Okay, looking into section 2.3. Okay, and this is going to be the part that has both log and synthetic division. And okay, now we have, first of all, we're looking at division of 4x plus 5 into 12x cubed plus 19x squared plus 9x plus 7. And now, in terms of taking what we have here, okay, so we have, so you have 4x plus 5. Okay, this is going to be the divisor. And for the dividend, so I have 12x cubed plus 19x squared plus 9x plus 7. All right, so we have, looking at the first terms from the divisor and the dividend. Okay, so I'm going to take 4x into 12x cubed. 12x cubed divided by 4x. This will leave us with 3x squared. And then I'm going to distribute 3x squared over 4x plus 5. Now the object is going to be to eliminate the first term from the dividend as I progress from one stage to the next. Okay, so I have 12x cubed, 3x squared over 5. This will leave us with 15x squared. Okay, and now applying the difference, subtracting what I have here. Okay, so we have 12x cubed minus 12x cubed goes out. And we have 19x squared minus 15x squared. So this will leave us with 4x squared. And I can bring down the remaining terms from the dividend. Okay. All right, so I started out taking 4x into 12x cubed. Now if I take 4x into 4x squared, that's going to bring us to x. We have x over 4x plus 5. This will be 4x squared plus 5x. And looking at distributing subtraction. Okay, so we have at this stage, okay, so we have 4x squares will go out. 9x minus 5x leaves us with 4x. And we have breaking down the 7. Okay, so we have 4x into itself goes one time. And distributing 1 over 4x plus 5. Okay, I have 4x plus 5. And if I take the product away, so we have 4x's will go out, and 7 minus 5 comes to 2. Okay, so we're going to have, in effect, okay, we have, with the quotient, this is going to be at 3x squared plus x plus 1, and the remainder is going to end up at 2. So just taking what we have now. Okay, so I have with the quotient, so I have 3x squared plus x plus 1, and we have a remainder of 2, and upon checking out, okay, now for the second item, it says use synthetic division to find out what will be the result whenever we take x minus 5 into this fourth order polynomial. Now for what I have to the right, okay, this is going to be your long division setup, okay, but I'm going to translate what I have in terms of synthetic division. Okay, so translating what I have going from long to synthetic division, I'm going to take representing x minus 5 will be the 0, which will be at 5. And so in crossing over to what we have with synthetic division, okay, so representing x minus 5, okay, so we have 5. And taking what we have from the coefficient, so I do not have any missing degree term. So I have 1 for x to the 4th, negative 4 for what we have in x cubed, negative 7 for the x squared term, 8 for the first order variable term, and we have closing out with the constant, which we have at 6. Now, and we have, with synthetic division, I'm looking at a process of addition, and instead of going from one row to the next, I'm actually going from one column to the next. Okay, so first coefficient I'm just going to bring down. So I have 1, 5 times 1 is 5. And then adding negative 4 plus 5 is 1. 5 times 1 is 5. Once again, negative 7 plus 5 will be at negative 2. multiplying 5 and negative 2, so I come out to negative 10. Adding together 8 and negative 10, I have a negative 2. 5 times negative 2 is going to be negative 10. And 6 plus negative 10 comes out to negative 4. And now for what we have in terms of the last column total, okay, we're going to have for the remainder is going to be at negative 4. And in terms of the quotient, now, when we started out with the 1 at the top, that was in reference to x to the 4th. And for each round of synthetic division, okay, the quotient is going to be 1 degree less than the original dividend. So this one at the front is going to be for x to the 3rd. Next line we have plus 1 x squared. Then we have negative 2 will be in reference to negative 2x. And we have closing out with a constant, which will be at minus 2. Okay, so just bringing down, okay, what we have here. Okay, so we have, so bring down 1, negative 4 plus 5 is 1. And again, we have 5. And then negative 7 plus 5 is negative 2. You got negative 10, negative 2, negative 10, and negative 4. Okay, now just for that little space that we have here, okay, so for the quotient, again, this is going to be what's going to be x to the 3rd. Yeah, that little box is going to have all these characters. And we have, say, x to the 3rd plus x squared minus 2x minus 2. And at the top, okay, is going to be the remainder. Okay, so we have negative 4 over x minus 5. And so in closing out and checking the result, and so in this one, okay, we had the result to be correct. Okay, it says here to find a polynomial of 3rd degree that has the following zeros. And it says to leave your answer in factored form. So we're not going to write this in expanded notation, but leaving in factor form. So you can say we have with, say if I have x is equal to negative 5, you can say this will stem from the binomial factor x plus 5. And in the case of 4, we can say that is going to be a 0 that stems from x minus 4. And we have a 0, okay, we can say that stems from x. And I can either leave x as a variable by itself without the parentheses, but I'll just go ahead and encapsulate everything. So we have upon checking, and so it's going to turn out that the result is correct. Okay, it says for number 4, it says to use the remainder theorem to find p of negative 3 for p of x is equal to x cubed plus 3x squared plus 8. Okay, and now for what I have here, okay, now we have looking for p of negative 3. Okay, so p of negative 3 is going to represent the remainder. Okay, now we have, okay, so we have with negative 3, we can say that negative 3 is a 0. Of the binomial expression x plus 3. So for what we have in principle, okay, so have x plus 3. So think of it like taking x plus 3 into this particular expression. Now, in the case of, if I were to set up what I have in terms of long division, so again, I have x plus 3 originating from negative 3. And I'm taking into, I'll show you why I'm doing the long division. Now we have a 3rd order term, and we have plus 3x squared. However, I am missing a 1st order term, but I need to add in a 0 for placeholder purposes. So I want every facet, okay, from the highest degree down to the constant to be represented. Now for the synthetic division for this setup, okay, so this is going back to the 0. So I have -3. For x cubed, I have 1. 3 for x squared. Again, 0 for the missing first order x term. And again, I want to close out with a constant. Had I missed a constant, I would have had another 0 at the end. Now we have with synthetic division. Okay, so bringing down the 1. -3 times 1 is -3. 3 and -3 is 0. -3 times 0 is 0. 0 plus 0 is 0. -3 times 0 is going to be at 0. 8 plus 0 is going to be at 8. And for what is going to happen in this particular case is that we're going to have that the remainder is going to be equal to 8. And in terms of the quotient, for the quotient, there is only a non-negligible term that exists. That's going to be at the front. Again, the one at the top represents x cubed, but after a round of synthetic division, this one represents x squared. Okay, and now we have with the quotient comes out to x to the second, and the remainder we have is equal to 8. And guess what? Whatever the remainder is going to be the function value of that particular inserted 0. And we have p of -3 is also at 8. So in terms of checking, and so that is correct. Okay, for what we have in the last problem case, it says use the factor theorem to determine whether x minus 2 is a factor of p of x is equal to x to the 4th minus x cubed plus 2x minus 5. Now looking at it, I'm just going to show you just with the long division setup. Then we're going to translate over to what we have with the synthetic division. So I have x minus 2, and I have into x to the 4th minus x cubed. Notice we have an x squared term that is missing. And I have plus 2x minus 5. For what we have along the lines of synthetic division, if I take the 0 of x minus 2, I have x equal to 2, and so just rewriting x minus 2 in synthetic division, taking the 0 of x minus 2, I have 2. Then we have the coefficients, have 1 for x to the 4th, -1 for minus x cubed, 0 for the missing x squared term, 2 for the 2x, and we have closing out with the constant, which we have at -5. Okay, so we have bringing down the leading coefficient. I have 1. 2 times 1 is 2. -1 plus 2 is going to be 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 2 plus 4 is 6. 2 times 6 is 12. -5 plus 12 is 7. Now, for what you would have for the quotient, okay, again, going from x to the 4th at the front to where this 1 at the bottom is going to represent x cubed. We have x cubed plus x squared plus 2x plus 6. But for what we have in terms of the question, now we have for the remainder is going to be equal to p of the 0 of the divisor. So the divisor x minus 2 has the 0 at 2, so the remainder is going to be p of 2. And the remainder is p of 2, which is equal to 7. And if x minus 2 had been a factor of this 4th order expression, the remainder would have been equal to 0. But since the remainder is equal to p of 2 is equal to 7, which does not equal to 0, it's going to follow that x minus 2 is not a factor. So we have just taking now. Okay, so we have p of 2 is equal to 7. And again, x minus 2 is not a factor, and checking out, and the result is correct.